Welcome to Summarize Science, where we break down complex research for everyone to understand. Today, we are looking at a paper that introduces a new way to evaluate how American football players move on the field using Bayesian multilevel models. Since 2016, the NFL has used high-tech RFID chips inside player shoulder pads to track their exact location 10 times every second. This tracking data captures speed, acceleration, and direction, providing a massive amount of information for every single play. The researchers wanted to solve a fundamental problem. How do you know if a player's positioning at any given moment was actually good? To do this, they used a concept called ghosting, which compares a real player's path to the path an average ghost player might have taken. The framework breaks down movement into 4 stages: characterization, modeling, simulation, and evaluation. This allows the researchers to simulate what an average player would do in the exact same situation as the real ball carrier. Look at this visualization where the black path is the real player and the gray segments represent 100 hypothetical alternative steps. By comparing these, the model can tell if the actual player moved better or worse than the average baseline. The study focused specifically on run plays by NFL running backs using data from the first 9 weeks of the 2022 season. In total, the researchers analyzed 5,400 individual plays to build their movement profiles. To simplify the complex movement of a human athlete, the study used a step-and-turn formulation. This approach is actually borrowed from how biologists study the movement and habitat preferences of wild animals. Essentially, every movement is viewed as a step length, which is the distance between points, and a turn angle, which is the change in direction. The model notes that as players take longer steps, they tend to turn less, while shorter steps allow for sharper, more erratic turns. The researchers used a Bayesian multilevel model to account for the unique styles of different players and teams. This ensures that the average baseline isn't just a random guess, but a statistically sound prediction based on the game's environment. One key finding was that a player's previous step is a great predictor of their next one, a concept known as directional persistence. This helps the model understand that a running back at full speed can't just teleport or make impossible 90-degree turns instantly. To make the data useful for coaches, the model translates these movements into expected yards gained. It asks, if the player took a different step right now, would they likely have gained more or fewer total yards? This chart shows the concentration of different running backs, which is basically a measure of how much they tend to wiggle or run straight. Players at the top, like Jonathan Taylor, are revealed as very consistent, straight-ahead runners who rely on speed over sudden cuts. On the other hand, someone like Christian McCaffrey is described as a shifty ball carrier who uses shorter strides to stay balanced and change direction quickly. The model provides a mathematical way to differentiate these unique running styles that were previously only described by scouts eye tests. The researchers can even track how a player's value changes throughout a single play. In one example, Javonte Williams started with inefficient movement, but eventually outperformed the average ghost by over 13 yards. 2 new metrics were introduced: yard success rate and explosiveness. Yard success rate tells us how often a player's positioning is better than the average hypothetical baseline. Explosiveness measures how often a player produces an outcome in the extreme top 5% of what was possible. Travis Etienne and Kenneth Walker topped this list, confirming their reputations as high-impact, big-play threats. To recap, this research shows that we can now use math to simulate thousands of what-if scenarios for every second of a football game. This allows us to evaluate players based on the choices they made relative to what an average player would have done. In the future, this could be expanded to evaluate passing, defense, and even multiplayer coordination. Thank you for watching Summarize Science. The future of sports might just be written in code.